Did your hamster die? That's terrible. Was it poisoned?
Probably. It's probably poisoned. I was like so freaked out. I was like, I'm showing my 2-year-old niece my hamster. I was like,
She didn't know. 2-year-old, what do you remember when you were 2? Nothing.
I probably remember an animal dying in front of me.
Probably not. Okay, complex numbers are numbers written in the form a plus bi, where a is the real part and bi is the complex part. So, what are we going to do? We're going to talk about graphing these complex numbers, not on the xy plane, but talking about if we call this axis the real axis, and this axis the imaginary axis, we could graph any imaginary point. Like, what if I wrote the number 2 plus 3i? Then, the real part would be 2, and the imaginary part would be 3. So, I could say I'm going to go 2 on the real axis and 3 on the imaginary axis, and that would be 2 plus 3i, or it would just be the ordered pair, 2, 3. Right? I'm losing 2 plus 3. So if I had a negative in front of one of those, like it could be anywhere, right? Like what if I did, let me make a point and you tell me what it is. Like what would this point be? Negative 3 plus 4i. What we want to talk about is the distance from the origin to any complex number. So think about if I drew in the line that connected here to here. You might say, what does this have to do with anything that we've been doing all year? Well, look what happens if I draw a line from here to here. Does this kind of make a lovely little triangle now? Oh my gosh, everything always goes back to trig. If I wanted to find the distance from here to here, do you agree that it's just going to be like the Pythagorean theorem? Like this kind of is like our r from our triangle, our radius. And so, when we talk about this distance, they always put it in absolute value bars because distance is always positive. And we say that the absolute value of a plus bi is just the distance from the origin to a plus bi. We also call that, I don't know what we could say, that's the, what do they call that, the modulus? That's a weird word, right? Modulus? But it's also just like the radius of the triangle that you could make. So maybe we could call that r. So would that just be the square root of this distance to this distance squared? So like the square root of a squared plus b squared? Hey, Eric, what's up over here?
Yes.
Are we in English class? Is it?
Every class deals.
Not this class.
Piss it off.
Right, this. I'm letting you go for a minute, and then you just keep going, you're going. And then you get angel involved.
Because I, when I looked at the,
I helped Miss Dawson use the copier today.
I had a lot.
When I went to make copies of your guys' tests, she was in there and like she pushed copy and only one came out. And she's like, I pushed 6 and only one came out. So then she did it again and only one came out. I said, you have to push the pound sign after you do 1 so that it'll come out. So I pushed it and then 12 came out. Okay, she did it twice. It depends on what you're doing. If you're stapling and hole punching and stuff, it's pretty slow. But if you're just doing like one to one side, it is pretty fast. If you want to plot this, that hopefully isn't so bad to do. You just have to remember the real axis is the x-axis, and the imaginary axis is the other one. What you need to make sure you know is this notation, right? If it says find this, it's just saying find the distance, which is just the same r we've always been finding, but you got to recognize that notation. So if I was going to graph this, I'm only going to make the points I need. If I'm going to do 4 minus 2i, that'd be 4 and then down 2. 4 minus 2i. You don't really have to label it, you just point there. And then find the distance, or the modulus of the absolute value of 4 minus 2i is just the square root of a squared plus b squared, which is just going to be the square root of 16 plus 4. You think I want you to leave this square root of 20? No. You think I want you to give me a decimal? No. Simplify. That's the square root of 4 and the square root of 5, so 2 radical 5. That's just the answer of the modulus, or the distance. What we want to do is we want to be able to change from complex form, which is a plus bi, we want to be able to change it to trig form. That's what this section is called, trig form of a complex number. So, let's talk about where this comes from. So, I kind of drew a little arrow over here for you. Maybe we should put a dot here and call that a plus bi. And let's say z equals a plus bi. What I want to do is be able to represent the angle that goes to that point out there, just like we've always been doing, but now we're talking about a plus bi instead of talking about an xy coordinate. But think about if I measured the angle from standard position that measured up to here, I called that theta. The same way we've always done this, where we got all these values from, we could use this reference angle and we could draw in the triangle that corresponds to that theta. Wherever you are in this coordinate plane, you could draw in a triangle, a right triangle. And instead of talking about x's and y's, we're going to talk about the values that we would use here. So what would the distance from here to here be? We don't really know what this is, except for we know this is a plus bi, right? So can I just call this a? And I know you're wanting to say negative a because it's over there, but we want to just do a generic for no matter where it is. If a was negative, we'll put negative. A was not negative, so we're not negative. And this would be the y value, right? Or in this case, the b value. And what do we want to call this here? Yeah, that's the modulus, which is the absolute value of a plus bi, which is the same as saying r, so we're going to also call it r. So using that, what would the cosine of this reference angle be, which we know is also the cosine of that? Cosine would be what? Adjacent over hypotenuse, a over r, and sine would be b over r. So solving that for a, if I multiply both sides by r, do you agree that that would say a equals r cosine of theta? And b would equal r sine of theta? If you ever forget where that comes from, you can always draw a picture and draw a triangle and find that. But they want you to know that the a value in a plus bi is always equal to r cosine of theta, and the b value is equal to r sine of theta. So we can say if z equals a plus bi, that's the same as saying r cosine of theta plus, where do we want to put the r or the I in here? R sine of theta I. Agree with that? Just to simplifying a little bit, I could factor the r out of that and say that's r times the quantity cosine of theta plus I sine of theta. trig form of a complex number. I do want to say that this book goes a step further and uses a notation that I have never seen before in my life. I went and asked Mr. Allspaw if he'd ever seen it and thought maybe I was just old and out of the loop and didn't know this notation. But he's never seen this notation either, but the book uses it. So Ivy Tech Test uses it, so we're going to use it as well just so that you're aware of it. But since theta is the same theta, do you agree with that? Like theta is the angle in that picture, which means theta is going to be the same value. They simplify this one step further, and they use the C, the I for the imaginary, and then the S for cosine, and they write this as R times CIS of theta. CIS means nothing except for it's just shortening this up. There's no CIS button on your calculator, and if you're going to work it out, you'd have to go back to this form. But I'm just going to show you what we would do with this if it shows up. This is on the Ivy Tech test because I saw it on the Ivy Tech test, and I thought it was a mistake. Like, I thought that was supposed to be cosine, and it was just a typo. And then I looked in the section, and I was like, what does this mean? But it's just because they're just saving you a little bit of writing is all they're doing. Okay, so we're going to use this form and go to this form just so you can get used to doing it. Trig form is also known as polar form, so those are used interchangeably, so don't stress too much if you hear that, but it's the same thing. So trig form is also known as aka polar form, which I wrote down there. We don't really do polar coordinates in here like we did in pre-cal. This is as much as we do with polar coordinates. Okay, so let's practice doing a little bit here. So basically, you want to go from complex form to trig form, and you want to be able to go from trig form to complex form. That's pretty much the objective today. Tomorrow, we'll add and subtract, and we'll multiply with these, and that's about all we're doing with this section. So if this is in complex form, right, do you agree that this is like saying A plus BI right here? So if it's in trig form, complex form, you know right away that A equals 2 and B equals 2. Could you find R if you know A and B? Yep. Because R is just the square root of A squared plus B squared, so that's just going to be the square root of 4 plus 4, which is 2 square root of 2. Trig form, we eventually want to get to that silly CIS thing, but basically when I think of trig form, I think I want R times cosine of theta plus I sine of theta, which means I have my R. What am I missing? You're missing your theta. So this is where you could draw this out if you want, or you could just use the ratio that we know. If you know A, B, and R, you know 3 sides of a right triangle, and you can set up to find it, right? Like if, what is it? A equals R cosine of theta, you could say cosine of theta equals A over R, just using the equation. Or you could always draw the picture like we've been doing this whole semester. If I'm at the point 2, 2, I'm in quadrant 1, and I have a triangle that's 2 by 2 by 2 square root of 2. Maybe you just know what angle I'm at. What angle would I be at in quadrant 1 if the x and the y are the same point? Do you know? Yeah, I think I should be at 5/4 or 45 degrees. Sometimes it's not going to be so pretty, but if you didn't know that, I just want to show you that you could plug that in. If A is 2 and R is 2 square root of 2, you get 1 over the square root of 2, which if you rationalize is square root of 2 over 2. If it's in the unit circle, then you could just find the angle. If this was something not in the unit circle, how would you find the angle if you didn't know that? Like, what if it said cosine of theta equals like 7 over 12? Remember how you do that if it's not a pretty angle? You use your calculator, and what button do you push? inverse cosine. You could do the same thing with this. If you didn't know that this was pi force or 45 degrees, you could do inverse cosine of radical 2 over 2 or 1 over square root of 2, and it would give you 45 degrees in degree mode, or it'll give you pi force in decimal form on your calculator. But we can say we know this is pi force or 45 degrees. It seems like they use degrees a lot in this. I don't know, they kind of go back and forth. Yes.
Would it be possible, or like if it was not in a circle, for it to be like 12 over 7, and then it would be over 1, and it would be under 1? Is that possible? But not like,
I feel like if they give you the imaginary, if they give it to you already in A plus BI form, like it has to have an angle that goes with it. Does that make sense?
yeah.
So we have theta. So all we gotta do is plug this in now. So write in trig form. R is 2 square root of 2 times cosine of pi force plus I sine of pi force. What Ivy Tech says and what the book seems to do is they go that next step. Like the directions on your test for Ivy Tech say write in RCIS theta form. Like they tell you to write it like that. Which means if you've done this, all you gotta do now is 2 square root of 2, and you just change all of this to CIS of pi force. That seems ridiculous to me, but whatever. I'm kind of annoyed that they're teaching you this. I like this form better because this, if you worked this out, would give you 2 plus 2i. If you took 2 square root of 2 times cosine of pi force, you would get 2, the square roots would cancel out. And if you took sine of pi force times 2 square root of 2, you would get 2, and then you would have that I there. So they're equivalent. One just has trig in it and one doesn't, and that's why it's called trig form. But it seems like this is what they want in this silly class. What if they only gave you one thing like this? Can you tell me what A and B are in this? Yeah. This is like the same as 0 plus 4i. So if you graph that, where would it be? This way 4? This way 4? Up 4, right? Which means, think about any time we did trig and it ended up on the x or y axis, you can't really draw a triangle there, but we can find an angle there. So A equals 0, B equals 4. Can I find R? Is R going to also equal 4? So you didn't know you could work it out. 0 squared plus 4 squared just equals 4. Like it is the longest side. It is the radius of it. It's just a line actually, not even a triangle. If you weren't sure what the angle is, I hope that you would just look at this and say, well, if it's up there on the axis, it has to be at pi halves. But if you didn't know, again, you could work it out and say, what cosine of theta is always going to equal A over R, or sine of theta is always going to equal B over R, and A would be 0 over 4. So where does cosine equal 0? This is where it is important that you look at the graph. If this would have been negative 4i, would we say pi halves? No, if it was negative 4i, you would say 3 pi halves. So you do have to look where you are when you graph that. But since we're up in the positive, we can say that we know that theta is pi halves. So I kind of wrote a lot of stuff. You don't have to show that much work every time. But we could say R times cosine of theta plus I sine of theta is going to equal 4 times cosine of pi halves plus I sine of pi halves. Or they're going to say we're going to write what? How do you even say that? CIS? Their explanation for this silly CIS. It says it's just a common abbreviation. I don't think it's very common. they gave you, what am I at? Yeah, what if they gave you this and asked you to go back and put it in standard form? And I wrote it like this because I like this better, but then the next one I wrote in their silly CIS form. Cis. Kiss. We could say kiss. There's a hard C there. What do you know? Actually, you don't have to do anything here, really. You just have to work it out. Is cosine of 225 an angle that we know? 225, that's right here, right? And the ordered pair is which means if it's already in trig form and you just need to go backwards, all you have to do is work it out and you get the A plus BI form. Since this is exact, I kind of want you to give me exact answers. But could I just replace this with negative radical 2 over 2 plus negative radical 2 over 2? Can I do that? Like I'm just plugging in what cosine and sine of 225 is? Are. And then could we just simplify that? Is that just negative radical 2 over 8 minus radical 2 over 8i? Like it's much easier when it's in trig form and you just go to complex form because all you do is work it out. If it wasn't a nice angle, you just get to type it to your calculator. Or maybe you can type it to your calculator anyway. Especially those cheap calculators. But sometimes they just want the decimal. Right, so now you have your A and you have your B. And you can check that it really does work, that you get that equal. I really just have one more here. Questions about that? But the book's kind of silly, so what if they gave you this one? Square root of 34 cis 49. CIS 49. I think this is where you do have to do that extra step of rewriting it, like change it back to cosine and sine. So like if I had this, the first thing I would do is say square root of 34 times cosine of 49 degrees plus I sine of 49 degrees. Is 49 degrees on our on our unit circle? No, which means they just want a decimal answer. So you can just take the square root of 34 times cosine of 49. And yes, normally we leave square roots, but cosine of 49 is already a decimal. So that would be silly to give me a decimal with a square root. So I would just take in degree mode. This is in degrees. If it was in radian, make sure you put it in radian mode. Square root of 34 times the cosine of 49 degrees. And let's just go to two decimals. I would get 3.83 plus the square root of 34 times sine of 49 degrees. 4.40. So let's do 4.4i. And that, not very pretty complex number, is what goes with an angle of 49 degrees and a radius of the square root of 34. That's the answer. So today was just kind of about the notation and being able to find the values, and then tomorrow we'll do some operations with it, and then that's it. Tomorrow should be the last new day of chapter 8, and then we'll review for a quiz on Thursday, and then we'll review for the chapter test next week. So here's your homework. I do have the packets for you. So I have you doing 24 through 33 multiples of 3, and those are just putting in trig form, like they're in complex form, you put it in trig form. And then 48 through 54, those are in trig form, and you're going to go back to complex form. And we'll see how we do on those. Those 54 was a little tricky with that first game comment. And then tomorrow we'll do kind of the 57 to 66 for multiplying and dividing. And then maybe a little bit like case six. So I went ahead and included the chapter review in this packet so that I shouldn't have to make you any more copies, hopefully, for this chapter. started, or if you have questions about the quiz, let me know and I can help